Kavin, are you there?
Yes, I'm here, sir.
Okay, let's get started. If you difference equation. What's the difference between difference equation and differential equation? You can see from here, differential equation involving continuous time equation. Like this is the continuous time equation. When you want to find a slope and some point, you use a dy dx dt in this case, and plug in the value of time. X is a function of time. You plug in the time and then you get the answer. But in difference equations, is the discrete version of the differential equation. Yeah, in discrete difference equation concerns about the discrete points. You see discrete points. So if this is the current point, then what is the next point? You write an equation for that. Okay. The difference equation in general has this form. Okay, like this is the output, present output, this is the present output. The present output, and this is like some coefficient A1 multiplied by a past output. And then this one is like also a coefficient multiplied by 2 past output. So this is what the difference equation doing. It's just summing up all these outputs. Okay, the output part of it. And this is the input part of it. This is a current input. Multiplied by some coefficient, and then this coefficient B1 multiplied by past input. A sequence of numbers. Let's say these numbers can be discrete form like this, like 5, and then you have 10, 5, 10, and then 20, and 40, and all this. So you have a sequence of numbers. So how can you write a difference equation for this? If you look at these numbers here, it's 5, and then 10, and then 20. The current value, let's say if this value is 5, the current value is 5, the next value is 5 times 2. Then if this is the current value, and the next value is 10 times 2, multiplied by 2. So the equation say the next value, y subscript n plus 1, is going to be 2 times the previous value. So that's a different, you can write a difference equation for that. So just to give you some idea, physically what it means. So now we can bring this over here, and yn plus 1 minus 2yn is equal to 0. So this is a difference equation, a simple difference equation. Okay, now we look at how to solve a difference equation. past and present output. Now the question is, we are doing the same thing that we did for the differential equation. Remember how we found during the last session, we solved a problem to find the frequency response and the impulse response. So now we're doing the same thing for the discrete version of the differential equation, which is called the difference equation. Okay, not h times e to, h as a function of e to the power of j omega. H as a function of. Then the next, we're going to find the impulse response. Fourier transform of y with n pass value n pass value is the same thing as time shift. Shifting the time by n, capital N, not the small n, capital N, this capital N. Time shift or delay for past value. So the Fourier transform of that is e to the minus j omega n. The delay in time domain is expressed as an exponential function e to the minus j omega n. It's a function of e to the j omega. So that is the Fourier transform of a time shift delay in a difference equation. If n is 0, then there's no delay. N is 0, that means there's no delay, there's no past value. It's not past value, it's current value. So the Fourier transform so if n is 0, then it's going to be just little n. Big N is 0, capital N is 0. So the Fourier transform of this is going to be e to the minus j omega 0. Okay, that's all you need to know to solve this problem. Apply the Fourier transform to the entire equation on the left and right to the output and input. E to the j minus j omega multiplied by, according to the formula we had earlier, remember? Okay, the next one is going to be plus 1 over 6 e to the minus j2 omega e to the power j omega. That's equals to, is this dark enough or should I make it darker, thicker, the line? Or you don't care, okay, never mind. Equals to, okay, the Fourier transform on the right side is going to be x. Okay, when you do, after you do the Fourier transform, all the lower case become uppercase, x and y's. Everything becomes function of e to the j omega. Okay, the Fourier transform of this, discrete Fourier transform of this. I think I've done, did I do? Okay, the discrete Fourier transform of this one is this one. The discrete Fourier transform of this part is here. The discrete Fourier transform of this is right here. For one pass value, you have e to the minus j omega. For two pass values, you have e to the minus j2 omega. And if there's no pass value, then it's going to be e to the power of 0. It's simply 1. It won't show up. And now here at the output, it's the current, at the input. It's only current value. There's no delay. So simply it's going to be x as a function of e to the j omega. Next, you know what to do, right? Next, you know what to do. The same as what we did for the continuous time domain differential equation. Next, what we do, we vector out the e to the j omega. So it's going to be 1 plus 5 over 6 and that's equals to x is a function of e to the j omega. Don't put the e too big. Okay. Then the frequency response h omega is equals to output, which is y e to the j omega divided by the input. That's going to be 1 over all this. Easy. Okay, so that is the frequency response. So this is the frequency response. Then part 2, is find the impulse response. So let's do the partial fraction. Partial fraction, if you look here, we have 1 here, right here, 1. So therefore, what times 1 gives you 1? 1 times 1, right? 1 times 1. So 1 times 1 gives you 1. So what times what is going to give you, what times what is going to give you this? So there's many things, you know, it can be 1 over 2. First, we look at this. First, we look at this part here. What times what will give you 1 over 6? It can be 1 times 1 over 2 also gives you 3, will give you 1 over 6, or 1 multiplied by 1 over 6 also gives you 1 over 6. But which one do we choose? Before we can choose which one, we have to think about this one also. So we have to choose this combination in a way, such a way that we should be able to get this also. So that's why I'm going to choose 1 over 2 multiplied by 1 over 3. 1 over 2 multiplied by 1 over 3 gives me 1 over 6. But what times what gives you e to the minus? Now what times what gives me this part here? That is easy, isn't it? E to the j omega multiplied by e to the j omega. It will give you e to the minus 2 omega, e to the minus j2 omega. So if you multiply them out, you can see you can get 1 over 6 e to the minus j2 omega. Okay, you already met. This condition is met, and then this one is already met. What about this? How do you check that? The way to check that is you have to multiply this way. You have to multiply this way and add them up. 1 times 1/2 is going to be 1 times 1/3. If you add them up, you'll get 5 over 6 e to the j omega, right? But this is minus. If you look, this is minus here. So what I need to do, I have to put a minus here. If you put a minus sign here, then you will end up getting minus here, and then minus there. Also, when you multiply these two together, it's still plus 1 over 6. So my factors are 1 minus 1f e to the minus j omega. And then the other one is 1 minus 1/3 e to the j omega. So these are my factors. One minus then you multiply by the denominator on both sides. We get 1 is equals to A. 1 minus 1/3 plus B you let each term go to 0. First, you let this go to 0. Okay, now by solving for e to the minus j omega, you get minus 3. You take that minus, you just replace wherever you see e to the minus j omega with minus 3. Okay. So therefore, this is going to give you 1 is equals to, we already said this equal to 0, isn't it? So 0 plus b. And b 1 minus 1/2 minus 3. Sorry, okay. Minus 3.
Sir, should be 3, am I right?
Should be 3. Yes, 3. Correct. 3. Thanks. So then now you solve for b. One is equals to so b is sorry, b is minus 2, is it? That's going to give you what? E to the minus j omega is 2. Am I right?
Yes, sir.
Okay, thank you. Next, you plug into, let me, okay, next you plug into the above equation. Okay, never mind, I bring this over here a little bit. One equals to A 1 is equals to 1 minus 2/3. So A is 3. Minus 2 over. So this is going to be 3. The A, what is A is minus 1/2, right? But then you put 1/2. This is A. This formula here, right here. Use of N. And then minus 2, 1/3. That's impulse response. The minus 1/2 here is right here. Minus 1/3 is inside here. This constant minus 2 is here. 3 is here. This applying this formula. A has to be, the magnitude of A has to be less than 1. So if you come and check if your magnitude is less than 1, of course, you know, this is your A. So like this is this part, this is your A. And A, the magnitude of A, the whole thing, this is the magnitude of A. This is the 2. And it's of course less than 1. Any question? Any question?
No, sir.